We want to find the temperature of the coffee after 12 minutes. Even if the graph isn't drawn out, if you think about where things are supposed to be on the graph, so minutes are on X, temperature's on Y, that can help you to know how to use your equation. We're being given a piece of information right here, 12 minutes. Okay, that's minutes. Where's minutes on the graph again? On the x-axis. So the pieces of the equation match with the pieces of the graph. So if minutes is on X on the graph, where do you think I should put minutes in the equation? Yeah, that's why I said thinking about where things go on a graph can help you to know where to put things in an equation so that you're using the equation correctly. Since minutes goes on X on the graph, we're going to put it in for X in the equation. So our work would look something like this. I'm going to zoom this in so we can write down our equation with that filled in. So y equals 160 minus 4 times 12. You see how I dropped the 12 in to the X spot? And it says find the temperature. Where's temperature on the graph? On the Y. The Y is sitting there. So when I figure this out, it's going to give me Y, which is the temperature, right? So now this is just a simple calculation. What's 4 times 12? 48. 48. So to get Y, it's going to be 160 minus 48. Okay, so what is 160 minus 48? 112, yep. 112, and remember, what am I finding? I'm finding the temperature, so I can label it degrees Fahrenheit. So there's my answer. I'm going to put a little note here. Be a good idea for you guys to put a reminder as well. We filled this into X because this is minutes, and minutes is on the X on the graph. So minutes is on the X-axis of the graph. So we fill it into X in the equation too. So wherever it is in the graph matches with what part of the equation you want to use. And that's why I said visualizing the graph is really helpful. See if we can use that same idea over here. Oops. Find the amount of time it will take for the coffee to cool to 70 degrees. Where would I want to fill that into my equation? 70 degrees.
Y-axis.
The Y, because degrees is on the Y-axis. So that means degrees, I'm going to drop into my equation, but I'm going to drop it in for the Y since it's on the Y-axis. So now it's going to look like this. In my equation, the Y is over here, right? So that means when I fill the 70 in, I'm filling it over here where the Y is. It's going to look like this. 70, I just replaced the Y, equals 160 minus 4. Oh, look, it's a two-step equation. Okay, we can do this, right?
Divide -4.
What's the first thing we want to do?
Minus 1.
Yep. Okay, what's that going to give me? Negative 90.
Oh.
Now what? Divide by -4. Okay, and so we kind of went negative, but it worked out in the end, right? Because negatives divided by negative, I'm going to end up positive. What's negative 90 divided by -4? There we go, yeah. Several people got it. Okay, and then what did I just calculate? X, so I'm going to label it as minutes because minutes is on the x-axis of the graph. That's not something we would have been able to read easily off the graph, 22.5. That's where an equation comes in handy. An equation can help you calculate things that might be difficult to see on the graph.